Okay, today we are doing day 3 of logs equations and solving exponentials and logs. Most of these are logs, and here's a rule I want to get off the on the table right away. If you have it down to a log on both sides, a single log on both sides, then you can set the arguments equal. We're always going to make it so the bases are the same, otherwise, well, I shouldn't say it that way. If we make it so the bases aren't the same, you can't solve it. But if the bases are the same, like this, then you can just say that has to equal that. X must be 5. Done. Or if it was 3x equals 15, then you could solve that little equation and get your answer that way. Okay, but if you have logs on each side, it's almost like those cancel each other. All right, so what happens if you don't have a log over there then? Well, then it's a rewrite situation. Please rewrite that, and you'll have the answer like that. 3 to the second equals x. 3 to the second's 9. There we go. See how simple that was? What if it was like this? Log base x of 5 equals 2. Solve that one. To rewrite. Again, if you don't have x's or logs on both sides, it's not something you see every day. Was that here when you guys got here? Okay. It's almost as if, well, Hammer, you're often sitting there charging your iPad, like somebody just turned you into a hamburger. Yes, there's a pristine hamburger sitting on that chair right there. Right in the middle. Yep. Probably just so we talk about it like we're doing right now. Anyway, you should have said x squared equals 5. And then you should have took the square root. And so x equals square root of 5. What did I do wrong? I'm losing points. Plus and minus, I did a square root on both sides. It's so easy to forget that. If you square root both sides, plus and minus. Okay. Now, wait a minute though. Hold on. There's two answers. And one of them is extraneous, because when you put that in, that negative that I just barely remembered to do, a negative right there is not allowed. So that's another thing to watch out for on today's. Instead of just getting answers, you'll get answers, and sometimes they don't actually work. Okay, so for today, what's different? This is day 3 of solving log and exponential equations. It's that the equations you get are going to be a little more complicated. And when you do get the answers, you better check them to make sure that they aren't extraneous. Like if they make the base negative or 0, or if they make the argument negative 0, or one more thing, that base can't be 1. I don't know if you remember that one. That's situations that would crash your function, and therefore those would be extraneous answers. So the negative one here does not work. And you should really even identify it and say x equals negative, x equals negative square root of 5, cross it off, ext. Because see, if you just don't list it, you could have just forgot about it. At least I remembered that negative square root of 5 was an answer, and then I ruled it out because it's extraneous. Okay, so what if you have logs on both sides, but there's 2 logs on the left side, and there's only 1 on the right side? Well, what if you condense the one on the left, and then you'd only have 1 log on each side? Try that. I betcha you'll get those log base 2s. It's kind of like they cancel, and then you can set the arguments equal, and it should be pretty easy from there. I'd like you to compare with, for you guys, it's the person behind you. You two, it's across from each other. Here, you're going with the person across. You guys are doing a little group of 3 right here, or 4 if you want to be included. These 2 right across from you. These 2 rows right across from you. These 2 right across from you, except you're going to have to do double duty so that Joe can have something. Okay, see if you got the same thing as they did. Here we go. This one combined together, this part that's called condensing, log base 2 of 5x equals log base 2 of 10, and then you say that's equal to that, therefore x equals 2. That should have been an easy one. All right, a quick reminder, let's just take the logs all out of this. Let's say that I had done something genius and I'd gotten my answer down to this. X plus 3 times x minus 4 is equal to 5. Do you remember how to solve quadratics like this? First outside and to last, let's do it. First is x squared. Outside and inside makes minus x. Lasts make what? Negative 12 equals 5. But then you got to set it equal to 0, so subtract 5 from both sides. The negative 12 becomes negative 17. Now it's equal to 0. Yay. Now can you make some way to multiply to 17 that will add to negative 1? Not going to work out nice. So if you can't factor it, quadratic formula. Now just stop for a second. What could I have put right here that would have made it factor nicely? 17 can only be factored into a 1 and a 17, so a 16, a positive 16 could have worked. Okay. Imagine for a moment that the problem is like this. Everybody factor it and tell me the two answers. There will be two answers. It's vectors because I changed the term. But the ones on the worksheet that you have, pretty much 9 times out of 10 they will factor. On that rare occasion where they don't factor, quadratic formula solves. All right. Check with that person, see if you got the same thing. Pause for a second where you do that. I'm back, and here is positive 16, positive 17, and negative 1. How can I know I'm right? Because first make x squared, outside and inside make positive 16x, and the last make negative 17. So then my two answers would have been x equals negative 17 and x equals 1. Now, the problem with this problem is that I didn't tell you the original problem it came from. If the original problem it came from had an x in the base, do you get how that one probably would crash and burn? All right. All right, so let's do one where you end up with a quadratic like that. Log base 3 of x plus 1 plus log base 3 of x minus 2 is equal to log base 3 of 9. I hope you see log base 3 of 9 and go, oh, I know that one. There's a number for that. It's just a number. Now, there are two ways to do this problem. I'm going to show you the first way in black, and then I'll show it to you a second time in red. This part right here, either scenario, you have to put those together. Log base 3 of x plus 1 times x minus 2. Because this plus has turned into a times. Okay, and that's equal to, now you can either say it's equal to 3 squared is what 9 is, right? So then isn't this thing the same as 2? Yeah, it is. And then you do a rewrite. 3 squared equals all that. Or, if you don't want to do it that way, you could keep this as a log base 3 of 3. Right there. Or log base 3 of 9. And say log base 3 of 9. And do you get then that will equal that, because the bases are the same and there's a log on both sides, without the rewrite even. Either way it works. Okay, so now that equals that either way, so now I got to deal with that. X squared first, outside and inside makes minus x, last makes minus 2, equals 9. I can't just factor it right now because it doesn't. It hasn't been set equal to 0 yet. So, you guys move the 9 over, see if you can factor it. If you can't factor it, quadratic formula. And you're all done. Make sure your answer doesn't crash the function. It is. But if you make it equal to 2, I just showed that as an alternate way of doing it. So if I make this equal to 2, then I'm going to go 3 to the second equals that, which basically means 9 equals that. Anyway, either way, it's 9 equals the other stuff. For right now, do you get that if that and that are the same, this has to equal this? You get that? Does that work in your head? Another way to think of it is it's sort of like that cancels that. It doesn't really mathematically cancel it, but it works out that what's left is equal to each other. If you'd have done it the other way, you just have to trust me that after you rewrote it, it would still come out to the exact same thing. So did it factor or not? Nope. So it's x squared minus x minus 11, and then that does not factor, and then you go x equals negative b, negative 1, plus or minus square root of b squared, which is negative 1 squared, is 1, minus 4ac, 4 times 1 times negative 11, all over 2a, and the 2a is 2. So, I've got this part right here is positive 44, and 1 makes 45. X equals negative 1 plus or minus the square root of 45 all over 2. Now, can I get it further? Yeah, 45 turns into root 9 and root 5, and that's really 3 root 5. But that one's kind of icky, because now it's hard to tell which one of these answers will crash my original function. You get if this is a negative number, that it might crash it if the negative number is bigger than 1, then my argument will become a negative. Or in here, if it's a negative number at all, and then you subtract 2, it's going to crash it. So which one's negative? The plus or the minus? Minus 1. So x equals negative 1 plus and not minus, because that one's going to crash. 3 root 5 all over 2. And I happen to know that 3 times the square root of 5 is still bigger than negative 1, and therefore it's positive. It's a positive answer. So this one works because it's positive. The other one can't work because it's negative. All right, that was a tough one. Sir? You are correct. Negative b, negative of negative 1 would be positive 1. Rats. Okay, doesn't really affect it. The final answer is still positive 1. You are correct. It is positive 1 plus. You didn't need the plus there, of course. So 1, you just say 1. Thank you. Just a little oops on the b not being negative. Okay, so let's do some of your worksheet problems together. Everybody find the worksheet. Watch out for quadratics. Oh, here's another place you see quadratics. Everybody look at that for a second. It may not look like a quadratic, but if you take the log x and just substitute it for just a plain old x, remember us doing that? It's called a u substitution. You say, I'm going to let log x just be equal to u, or x, or whatever you want it to be equal to. So then this becomes a u, and this becomes a u, and then I have u squared minus u equals 0. Can I factor it? Yeah, and if you can't factor it, you should. So I can factor that. U comes out, and I'd have u minus 1 as the rest of it. Okay, then I'd have two answers, one for this, one for that. It's like that. I'm going to back up in time now because a lot of people are distracted because somebody just walked in late. Understandably, I know where you were and stuff. But okay, so everybody take that, factor it, please. This you will find, I believe it's problem 10 of your worksheet is one just like this. Getting you ready for, it's going to be number 14, it's day 3. Or is it 15? Could be number 15, but it's day 3 either way. Did you factor this log out? Okay. I know, that's the problem with me telling you to look at your worksheet. And immediately I lose everybody's attention. There's a log in both of them. Comes out, log x, and then what do you have left? If this was log x squared, you still have a log x left. And then minus, when I take the log x out of that, I have minus 1. And then I set this part equal to 0, log x equals 0, and this part equal to 0. I'll do it in blue. Log x minus 1 equals 0. Then I add 1 to both sides, and this becomes log x equals 1. How do I solve those? You gotta remember, they have a base you're not seeing. This is another theme with logs, is when they don't tell you the base, you should put in the base. I get the feeling you're not with me. What's the base? Base 10. Then you rewrite this and you say, oh, so 10 to the 0 is equal to x. What's 10 to the 0? X must equal 1. Does that look like it'll crash my function? Nope. And then I go to the next one. Log x is equal to 1. Base is 10. 10 to the 1 equals x. X equals 10. Neither one looks like they're going to crash my function. My answer would be 1 and 10. All right. Moral of the story. When you get these log problems simplified down their equations, don't be surprised if a few of them are quadratic. Don't be surprised if those are the kind you see on the test, because we don't usually make the easy ones be the test question. Unless it's just gimme R2, sometimes we throw in a nice easy R2. Yes? Okay, where is the 1, though? The 1's not in the argument. So this is 10 to the power of 1. 10 to the power of 1 equals x. All right, so now let's do some of your worksheet. If you haven't already, please find your worksheet. I believe it's been correctly called number 15. Is that right? It's called Solving Exponentials Day 3. Okay. There's one on here that, for me, is really tough. The rest of them, not so bad. All right, look at number 1 here. One thing I told you at the beginning, and I don't know if you caught this or not, was that you want to get it down so there's only one log on each side. That means on a lot of your problems you are doing, I keep wanting to call it compression, but it's not that. What is it? Condensing, right? You're going to be condensing the left-hand side. That way you'll have one log on each side. Hopefully it's a log base 6, and then when you have one log on each side, it's like they cancel. No, they're not really cancel. So log base 6 of x over, because minus makes a divide, x minus 1 equals log base 6 of 3. And it's like these cancel, because what's in here has to be equal to what's in there. The arguments have to be equal. And again, I know people get annoyed, but the point of this worksheet is that you already had done problems like this. The algebra gets a little harder. At the very beginning of the year, I told you, clear fractions. Wherever you can, you clear the fractions. So I am multiplying everything by x minus 1 here. There are some little good, like, life tips for pre-calc and for calculus One of which is if you can factor it, you should. Another of which is if you can get rid of the bottom of the fraction, if you can clear the fractions, you should. So I just multiplied by x minus 1. That cleared this. It's not a fraction anymore. And from there, it is simple algebra. You can just solve that little equation. There's not even an x squared in it. So you'll just get one answer and you're done. What happens if the answer comes out negative? Watch out. Because I'd want to make sure that in the argument here, I can't have a negative number. Even if the answer came out to 0, do you get how it would get messed up? If the x was 0, 0 minus 1 means I got a negative in the argument. That would crash. So double check yourself that you aren't getting answers that would crash. All right, let's move on. The next few are just condense the left side. It'll be easy. This one, a lot of people are like, but I condensed the left side and the right side doesn't have a log. Every kid that has come up and asked me for help on these, it was at the point where they should have done a rewrite that they got stuck. This is the point where you'd want to do a rewrite. Can you rewrite this one? Just looking up. 7. Start with a 7. You got it. 7 to the 1 is just 7, right? Is equal to... Exactly. And let's actually multiply that out. First is x squared. You are correct. You are correct. Good job. And now if you just subtract 7 from both sides, I bet you it'll factor. The person who makes these worksheets really likes factoring. So 9 times out of 10, it comes down to an answer that can be factored, and then you get 2 answers. And then what do you have to remember? What about your 2 answers? We have to watch out for extremes. Watch out for negatives that are in the face or negatives that end up in the argument. And if the number, when you put it in, causes it to be negative, you got a problem. But do you get that even like 4 would cause the argument to be negative here? So just get in the habit, if you want an A on this DEX test, of taking all your answers, especially if there's 2 of them. Oftentimes happens with quadratics. And double check both answers. Put them both in and make sure that they don't actually crash. Alright, so let's finish this. 0 equals x squared minus 4x, but subtracting 7 from minus 12, then that factors. X minus 4x plus 3, no, that's not it. Outside and inside aren't making negative 4. Help me out. 6 and 2? Is it minus 6 and plus 2? Awesome. Okay, then my answers are x equals 6 and x equals negative 2. One of those things isn't going to work. The 6 is okay because I can have an argument that's 1. It just turns the whole thing into 0. The negative 2 is the one that's going to crash it. Negative 2 when it's put right there or there. Crashes either one. Crashed either one, you got a problem. So that one, EX. Okay. So again, hints for you. Get it down to 1 log on each side. And if you can't, like, look, there's no log over there. Then do a rewrite. So this one, once you condense the left side, you're just going to do a rewrite. Usually kids get stuck on either the quadratics, which usually are just multiply it out and get it set equal to 0 and see if you can factor it. And the other one that they get stuck on all the time is they just don't know what to do. There's an x in the middle of their log problem and they don't know how to fix it. Rewrite solves it 9 out of 10 times. There is one on here that I would like to leave as a challenge question and not tell you how to do. Every now and then, you need a good challenge. That one. Anybody can figure that one out without my help, and I'll be very impressed. Okay. That's all I got for you for now.